We're a social enterprise that is basically focused on catalyzing the space industry here in New Zealand. And we have basically a full lineup of space specialists that are going to be talking about the future of space and New Zealand and the theme for tonight. So before we start off, I also wanted to give a little bit of a background for our panelists here. So let me just get my information going here. So in no particular order. Dr. Sarah Kissans is a synthetic biologist and a research fellow at Canterbury University working on solutions to climate change and colonizing other planets. Dr. Kurt Joy spatial and data visualization company headquartered here in Christchurch. Aisha Burma is a co-founder and president of the New Zealand Space or Student Space Association in Christchurch, and the chapter, and a second-year undergrad at the University of Canterbury studying astronomy and mathematics with a passion for the stars. We have Tim Searle, who represents the New Zealand Space Agency. He's a senior policy advisor at the New Zealand Space Agency. Previously, he has been working on public and private sector space projects in Europe. His key technology-focused domains are hybrid propulsion, small launchers, UAV applications, and space debris mitigation. And our last panelist is Eric Dahlstrom, who is the co-founder of SpaceBase. The reason why we have the same last name is that he's also my husband. He also supports space entrepreneurs here in New Zealand. He's an astronomer, a space engineer. He's on faculty for the International Space University and has worked on space station design for NASA. So we have a lineup of speakers that basically spans the gamut from government to industry to academia. And so really, really interesting to see how the discussion and the questions come up this evening. So maybe to start off, just to kind of like prep our theme for tonight, you know, for the past 2 to 3 years, most of you would probably see that there's like a really big jump in the development and the growth of the space industry like globally. I mean, you've heard probably of Elon Musk and Jeff Bezos from Amazon, who's now looking at like missions to the moon and Mars. And so there's like a lot of the things that's happening. And that's out there globally. But here in New Zealand as well, as you can see, Rocket Lab is what they say that the kind of like the space unicorn that is now kind of like at the forefront of the the small launch market. And really it's interesting that New Zealand also is the 11th country now that can also launch up in space. Yep.
Unfortunately, there's an echo in the...
Yeah, I can actually hear the echo. So, can you actually hear me?
Oh, yes.
Awesome. Yeah. Awesome. Okay. So, like as I was saying, New Zealand is also, there's a lot of things that's happening in New Zealand today, not just outside. And why is this happening? Is because technology has been democratized. When I say that, it means that it's faster, cheaper, better. Software has now basically replaced hardware. There's a lot of things that are now available to everyone, not just to big governments and aerospace companies, but essentially to the entrepreneur that is out there, either if you're in India, in the US, or in New Zealand. So I kind of like start off with that then by saying that if this is happening, what is New Zealand's role? Like, what do you see New Zealand to be focusing and potentially be part of this global space economy? What are the technologies that you should be looking at so that it could play a role for this big missions that's happening in space? So I kind of like start off there and prep the panel. And so I think what we'll do is For the session, we're going to give each of the panel some opening statements to talk on the theme, and then we will open it up to questions and answers. And so what we've done is that there is an app called Slido, and the way to...
It's up there.
Oh, it's up there. Okay, great. So you can basically put your questions on Slido, and the event code is 3748. You don't need to have an account. And I will be looking at the questions and fielding them to the panelists later on. All right? Okay, well, I think I'll just make it simple and go from left to right, and we'll start with Sarah.
Excellent. Thank you all for coming. It's really exciting to be here with a broad and deep range of panelists here. So I am a research fellow here at the University of Canterbury. So my background is in academic research. Definitely looking to take my research from academia into more of an applied sense in space. I'm a biochemist and a synthetic biologist, which when you think about biochemistry or biology, you don't instantly think about space. But they have lots of applications as we move from a country that just launches vehicles, that develops spacecraft, and is looking at satellite technology. As we begin to really look for colonizing space and to bringing humans further than low Earth orbit, we're really going to need to understand how to keep those humans alive in space. And what we can do with biochemistry and synthetic biology is actually develop systems for resource management, so water management, biological organic resources for food and fuel and pharmaceuticals, and for all the things to pretty much keep humans alive in low Earth orbit and beyond. So that's sort of my background, and New Zealand has a really strong experience and expertise in both biochemistry and synthetic biology and the development of agricultural products. And so we can take that from sort of a terrestrial expertise to actually working in space with these things.
I'm going to sneak in a question for everyone, because it's sort of like part of your intro. Somebody was asking, what inspired you to get involved in space? So if you can add that to kind of the intro.
So I'll add that. Again, typically you don't think of a biochemist growing up wanting to work in the space industry, but I grew up in the US, and I grew up in the shuttle era in the US, where I think every little kid wanted to be an astronaut. How many of you guys have ever harbored a desire to become an astronaut? So good. That's good that I'm not alone in this room here. I think there's quite a few of us that have wanted to get into space and wanted to think about living beyond the Earth. And so back in 2017, I applied to be an astronaut with NASA, along with 18,000 other people. So really, coming from New Zealand, coming from a biochemistry background, wasn't really sure how far I would go, but I was honored to go quite a ways through the process of astronaut selection, down to the top 50 of NASA astronaut selection. And so going through that process, getting to interact with the engineers and the astronauts, and basically all of what NASA does, really solidified not only my love of the manned space program, but what space can do for humanity. And so I'd like to do that here in New Zealand.
Eric?
All right. Hi, I'm Eric Dahlstrom from the U.S. And as Emmeline mentioned, we're here as co-founders of SpaceBase and supporting the development of the space entrepreneurial system in New Zealand. I started studying gravity theory, black holes, and then astronomy, radio astronomy, mapping the galaxy, and then became a space engineer, working for NASA on space station design. I think part of my motivation is in studying astronomy was just to see the tremendous scale of resources that are in the solar system in terms of energy from the sun and the amazing amount of material in the asteroids and moon and Mars, and just wanting to apply those tremendous space resources to improving life on Earth. And so I think we are at the verge of a transformation of moving out into the solar system in that way. Working for NASA, on NASA projects for decades, I was always chasing the big NASA projects around moving from NASA center to NASA center. And, but then 10 years ago, we moved to California and Silicon Valley, and there's this transformation that's been going on in technology, which is just the tremendous power of in your cell phones, for example. Like I used to always want to use a Cray 2 supercomputer, but this phone is more powerful than 60 Cray 2 supercomputers. When you turn on the phone, it asks you that you have to promise in the legal language that you won't use your phone to design nuclear weapons. So, but there's so some of our friends in California actually took their phone and launched it into space just to see if what would happen. And they were able to remotely control the phone and take pictures, and they just demonstrated that all this electronics, these, like, it used to be that a gyroscope for space was $30,000 and this big, and now it's a $3 chip that's inside your phone. And so they discovered that you could use phone components to make spacecraft, and they made the company Planet, and now they have 200 satellites up there mapping the Earth every day, just using low-cost technology like that. And so that's the transformation that is why everybody's interested in launching small satellites, and that's why New Zealand is really making a name for itself around the world. One other example that that we see a lot of potential in New Zealand for is that the small communities actually work in your favor. Do you want me to use this?
No, you're loud enough.
It might just be better for the people at that aspect.
Oh, okay.
Yeah.
Let me give this a try. Does that help any? Yeah, better? Okay. No feedback, please. And so, I'm not sure if that's an improvement. Okay, one example recently was a few months ago, there was normally it takes 2 years to build a satellite and then get it launched. And a few months ago, a satellite was built in Australia, and then 2 months later launched in New Zealand. And so suddenly it woke up the world that New Zealand can do things in 2 months that used to take 2 years. And not only was Rocket Lab critical for that, but also the New Zealand Space Agency worked really hard behind the scenes in order to enable that. So there's the small communities tightly working together in New Zealand is really an advantage, and I think there's a lot of potential for New Zealand's role in space activities.
Yeah, hi everyone. My name's Kurt Joy. I work for a local organisation called, or local company I should say, called Orbica. We do artificial intelligence, remote sensing, handle big data sets, do lots of cool stuff. So I work there as a remote sensor. I'm interested in orbital data that comes down and we can process to look at changes of the Earth. And as I was saying to Eric, it's slightly ironic that as a kid I looked into the sky, looking into space, and now I look into space at an instrument that looks back at Earth so I can look at the Earth. So it's slightly kind of ironic. And my introduction to this, if you go back a million years, I grew up in the late 70s and the 80s where my dad would wake me up early in the morning to start watching the shuttle launches on TV. So there was always this sort of idea that space was cool. It was the conquest of man and technology versus gravity. And the other great thing he bought me was in the early 70s, late 70s, actually 78 or something like that, there's a book called Landsat Images of New Zealand, which is kind of this famous New Zealand coffee table book where it had this amazing false colour imagery of New Zealand. And you could really see the Alps, you could see all the bays, you could see everything in fantastic detail. You now have gone on 30 or so years, you know, the data that's coming out of these satellites is pretty amazing. We're now getting down to multiple temporal visits a day. The same site can have imagery down to 30 centimetres a pixel. But there's still a cost involved, and part of this split of space going into commercial and the sort of more research and freely available data is quite strong. So as someone who comes from an organisation where we use all open source software, we try use all open data as possible, and this really sort of tags on this democratisation of space. We feel that, you know, New Zealand has a role to play in the Pacific of building low-cost satellites that can look at the changes on islands with climate change, look at the changes in New Zealand, and allow people around to have data easy to their desktops. You know, and that would be a fantastic thing for New Zealand. Cheers.
Thanks. Hi there. My name is Aisha Burma, and I'm a second-year undergraduate student at the University of Canterbury studying astronomy and mathematics. So what got me into astronomy? When I was about 5, my parents gave me an encyclopedia on science, and I would read it a lot. Just motivated me to do science. And when I was about 14, a lot of things happened. I heard that the Voyager spacecraft entered deep space. I started watching a lot of documentaries about space by Neil deGrasse Tyson. I read a lot of books. And basically that's what motivated me to start my career in astronomy. Why do I think astronomy is important to New Zealand? Well, we have Mount John Observatory at Lake Tekapo. It's New Zealand's only professional observatory. Now, what makes Mount John Observatory really unique is the latitude and longitude, the position that it's located in. It gives us really insightful and superior data compared to other telescopes in the southern hemisphere, like the ones in Chile and South Africa. And this is really important because this means that we can get a lot of really, really insightful things, and we can do a lot of astronomy research. And that's really important to New Zealand. And there's a push for dark skies as well. You might have heard that the Aoraki-Mackenzie Basin is a dark sky reserve. Well, if we have a lot more dark places in New Zealand, we can easily increase the astrotourism. And that's a really good thing for the New Zealand economy. So yeah, that's my motivation. Thank you.
So, hello, my name is Tim Searle. I'm working for the New Zealand Space Agency as a Senior Policy Advisor, which comes under the Ministry of Business, Innovation and Employment. So one of my roles is to help boost and build New Zealand's space industry. And I think the thing that got me into space, most of all, is that nowadays everything that we use is space-based. I mean, how many of you today used some form of space application to get here? I mean, that's Google Maps probably. So everything we do today involves space. And I think that we have seen that New Zealand has this great launch capability through Rocket Lab, but what we don't see is that there are hundreds of other businesses, small businesses doing cool things like Kurt, and then we have the university students, and we have people with associations, and we have mapping companies of space, and there's just hundreds of applications that there wasn't 5 years ago. If you told me that 5 years ago that there would be 70 people sitting in a conference room an auditorium in Christchurch on a Wednesday night ready to listen to space, I wouldn't have believed you. And now, I mean, we had these TechWeek events all over New Zealand, and we had a great turnout. And where do I see the future of space in New Zealand? I think it's important to build not just from the bottom up. So it starts in the schools and having people really interested in the STEM subjects, which I see a lot of young people here, which is pretty exciting as well. And then building right up the way to supporting small businesses that want to use space applications, right up to the big companies where New Zealand has an act that looks after and makes sure that everybody is safely and responsibly using space, which I think is really forward-thinking, and it's quite impressive for a very small country like ours to have sending things into orbit and then using the power of these for our everyday lives. So. Yep, that's my impression of space. Hand it back to MC.
Actually, you guys can hear me, right? All right. I'll leave the microphone for them. So yeah, being the moderator, I'm going to ask the first question. So you have so many different backgrounds and different experiences about space that's already happening here in New Zealand. So my question to you is like, if there is no, if resources is not a problem, what do you think should be the focus of New Zealand in terms of what is that technology or that niche market that you think New Zealand should be focusing on? So, anybody?
Well, I would like.
Space agency?
What should we be focusing on? Yeah, I would like to build on an earlier point of responsibilities for the Pacific and also for using space data and space things for good. So there's a lot of good opportunities to use space data and satellite imagery for after disaster. For example, in Christchurch, where you had a strong earthquake, and there's a lot of space-based applications that help rebuild cities and to grow things back to how they were. And also we have a lot of opportunities to track climate change, which is something is important for New Zealand. I think New Zealand has always been has had this clean green image, and we want to maintain that. And one of the ways that we can do that in a modern way on a larger scale for cheaper is using space data. So that's my idea.
I think one area that is New Zealand's very good at is cooperation in the small communities or between different subject areas, different disciplines. For example, in our experience in California, people would be in Silicon Valley would be working on projects that they think farmers would want to use. And they would work for years on it, and they wouldn't drive 100 kilometers and talk to a farmer. It was just bizarre. And so you would have these people just show up at the farmers and say, we've got this $10,000 technology to solve your problems. And the farmer would say, you're not even asking me what my problems are. So whereas here, for example, we just are in a process of starting this New Zealand Aerospace Challenge, is sponsored by MB and with Airbus and Christchurch NZ and SpaceBase as the delivery partners. And the challenge ends in September and October with a final competition to apply space technology and UAV technology to sustainable agriculture, detecting pollution. But we are doing a virtual incubator, and we just announced today the 18 teams that are entering the virtual incubator. And so they're going to be working for 5 months with support from Airbus and all these other partners. And but they're all there's some very impressive teams that are applying space data or UAV data to sustainable agriculture and have. It's just amazing that we just put up this $30,000 prize and we put out this problem statement, and suddenly all these innovative teams from across New Zealand emerged, and some established companies and some student groups and some startups that were formed just for this competition. And so the innovation is out there, and the energy and enthusiasm is out there in New Zealand. You just have to ask the question and say, frame the problem, and people come up with these ideas. And so I think New Zealand can move very quickly in doing things like this. Just to say that, if here's a challenge, launch small satellites in a better way than anyone else, and New Zealand responds.
We have that ability to collaborate as well. I think that, being a small country is, both a pro and a con. It can be sometimes really painful because we don't have leverage on the world stage sometimes, especially when it comes to satellite data. And of course, I'm going to say satellite data is an important thing because that's what I do. But, when we think about something like the Aerospace Challenge, this collaboration just forms. We had a small company in Otago come to us and said, we've got UAVs, we're doing this stuff. You guys are doing some cool stuff with, artificial intelligence technology and GeoAI. Can you come and join us? And we were like, yeah, sure, that sounds interesting. So we got through with LandPro. So it's a really interesting thing. And on this, you know, I keep on harping on about the need for data. And before I started working at Orbica, I did a 10 years worth of research in Antarctica. So I started off in my 20s realizing that slightly overweight, grumpy Kiwis do not go to space with NASA. So I figured there was no way I was getting to Mars. So I'd go to Antarctica. I'd work in the dry valleys. It's the second closest place on the planet you can get to it. So in that time, I've spent lots of time in that environment and gradually moved away from doing stuff on the ground to moving through these orbital platforms and orbital instruments. You know, and even within that time, we used to say 30 metres is amazing resolution. So one chunk of the ground that's 30 metres by 30 metres would appear as 1 pixel in an image, you know. And then someone would come up with 15 metre a pixel imagery and we'd be like, this is amazing, you know. And then we look now where we can go to worldview and we're seeing 30 centimetres a pixel on the ground, 60 centimetres a pixel. We can do really amazing things with this. And I think New Zealand has the ability to really come to the fore designing small satellites. You know, there's already a lot of them out there commercially, but New Zealand, I think, needs its own little flock of them, collecting real-time imagery of Antarctica, New Zealand, the Pacific, especially as we start going into climate change and the effect of that, especially on the low-lying islands. You know, we have the ability to monitor that, and we deal with a lot of companies who are really interested in monitoring change, and that's one of the most important things. And having freely available high-resolution data for all New Zealanders to use would be absolute tops on my list.
Yeah. I'm sorry. Just building on that point, we've got great initiatives in New Zealand. Like we've got Rocket Lab, New Zealand Space Agency, the SpaceBase New Zealand company. And that's great because we're putting New Zealand on the map. And that's really important because we're a small country with limited resources. But the fact that we're able to put New Zealand on the world map is pretty cool.
So there's a lot of questions now coming in. So slightly related to the question earlier, there's a question here. Where in the space industry of New Zealand lies the biggest potential for innovation, particularly through engineering? Any takers?
Having spent some time at Canterbury University today, I would like to sort of buzz in on that question briefly. I think that there's no one application area, sorry to ruin the question for whoever asked, but what I have seen is there's an incredible amount of knowledge and ability within New Zealand. So today from Martian habitats to construction materials for spacecraft to, I saw a challenge for Mars rovers also going on today, so robotics. There's an incredible amount of capacity in New Zealand and ability to build things. Also, I went to the rocketry department, sorry, I forgot about that. Saw some UAVs. So I think that there's no one area. I think that what New Zealand doesn't have is always these big, massive budgets, but what they do have is this number 8 wire ability to innovate and to develop new technologies where you have a problem and you just think, oh, why not? And instead of why should we, why not? And I think that's kind of where we have a good opportunity, and we have a lot of interested students right from the base level right up to small companies. And I think also the ease of doing business helps a lot as well, and it just builds up a good industry. And I just think that everything is a little bit faster, like you said earlier, Kurt, that there's just small communities and you can just go down the road to somebody and call them up and say, okay, are you interested in collaborating with me on this? And people could contact the space agency by the same token and talk about different things. So I think that's where we have a key advantage.
We're cheap. Kiwis are cheap. We like doing things on a shoestring budget, but at the same time, we're very cunning and we're very resourceful. And I think, you know, any of these projects can be done with the resourcefulness of Kiwis. You know, it just takes someone in their garage sparking a couple of wires together, getting an idea, getting a soldering iron, building something, talking to someone else, and the idea just spins and grows. And that's, you know, that's what New Zealand's great for.
I think that really allows us to develop niches that don't necessarily develop sort of in Silicon Valley where everybody sort of is talking to each other and might have the same ideas. Being isolated is a benefit at sometimes in that you can develop isolated ideas and you can collaborate with international partners, but the ideas that we develop here are sometimes out of necessity of having limited resources, but that gives us an advantage in that we can develop something that maybe not somebody else is willing to develop.
Talking about resources, or did I cut you off?
Sorry, go ahead. I'll talk.
I think you're allowed to, aren't you?
Yeah.
Talking about resources, there's a question here about what sort of level of government funding is available or planned to support the future of space in New Zealand?
I cannot. Thanks. So I cannot.
And will you be writing a check?
Not today. So I don't have an exact figure, but what I can say is that there are a lot of government initiatives coming up in space, and it's not a small issue for us anymore. It's quite at the forefront of a lot of people's thinking. So I think the government has it as a focus and as a priority, and it's no longer the fact that, oh, these space guys are just doing their own thing down over there. I think it's now come to the forefront of our attention, and I think over the next few years we're going to put a lot of support behind right from the bottom to the top of the spectrum, so right from the students again to the large businesses. And I think we have some ability to, let's say, be much more reactive with companies if they come to us more with a problem. I think Rocket Labs is a good example of that, when the actors made us a reactivity to them wanting to launch things. I think we have the ability to work with companies, and rather than just say that's your problem. And I think that the funding follows that as well. Sorry, it's not an exact figure, but yeah.
Great. So here's another question. What roles do you see appearing for space-related employment in New Zealand? What fields will be in demand? This is for everybody.
I'll say a few things. We've been at SpaceBase. We've been trying to make a directory of all the companies and organizations related to space in New Zealand. And if you go to the website spacebase.co, you can see the directory. When we first proposed this 2 years ago and talked to the government about it, they said, well, how many are there? 3 or what? So, but we found 200. So, one thing that's just we still haven't adjusted since coming from California is that how humble New Zealanders are. It's been driving us crazy. I mean, people do amazing things that they won't talk about it. They won't talk about what they're doing, and so we're switching to things like, tell me what your friend does, because they'll be quite happy to promote each other, but not promote themselves. So it's so we're working all the time on trying to develop the directory and get people to take ownership of their directory entry and expand it and things like that. But it's so one challenge in general in this new space era is that the companies that are succeeding quickly are reducing cost, and they don't have a huge employment and the employment really comes later when they really make it big. And so that's so even though there's lots of little things going on, it's not yet a huge employer. And so, but I think things like some of the connections with the ground, with the users, space in general in globally is like $360 billion a year, a global enterprise, but almost more than half of that is the ground equipment and ground connection, and so I think there's going to be a lot of opportunities in that area, especially for things like just in 2 or 3 or 4 years we'll probably have 5 companies competing to provide internet from space. And so if you can go out in any hill in New Zealand and get 1,000 megabits per second down, it can really transform how the country operates, and suddenly everybody, even more so, will want to come to New Zealand to live, to plug into the global internet. So.
Yeah, I mean, what Eric said about, the ability of moving data from these satellites to and forth back to the ground stations, is something we kind of forget about. Everyone goes, we want all these high-resolution orbital satellites that are capturing these huge amounts of data, heaps of times a day, what do you do with it? And that's a problem that will always happen, is that you've got something up there, low Earth orbit, 2,000 kilometres or something, or, geostationary orbit. You've got to get it back to Earth. Sure, things travel at the speed of light, but you're still moving a lot of data, and that's always going to be a problem. So, there's been a lot of work. Airbus and those sort of companies have spent a lot of work on their ground stations and the engineering behind new communication systems, so they can try to get this data from space back to the ground station as fast as possible, and this means that instead of waiting 24 hours, 2 days to get the data back from space to a ground station through a processing pipeline and to the user's desktop, they're getting them back every, 12 times a day possibly. So, it's a big thing, and I think, we sometimes think of space as this industry, and the reality is it's an environment. And it's all about the applications. We can send satellites into orbit, bully our way to space, fight gravity and get stuff up there, but the reality is we still have to do something when we're up there. And apart from manned exploration, the point of sending satellites up is to do cool stuff, whether it's Earth observatory, whether it's space observatories. It's all about the applications, and those applications are where the industries are going to be. They're going to be STEM, pretty much.
I have a question for Ayushi. What is the purpose of the New Zealand Student Space Association, and how do we get involved?
Great question. So the New Zealand Student Space Association it's an organization originally founded in Wellington, and it's a national organization. We are the Christchurch branch, and our mission is mainly to make science and space accessible to everyone. So anyone who's interested can join. We don't care how old you are, we don't care what you do. If you're interested in space, you come join us, and we organize different talks and events, public lectures, discussions, debates, even movie nights. And they all range across a range of disciplines in science, mainly focusing towards sort of astronomy and space. Because astronomy and space in general, actually, it's quite a highly interdisciplinary subject, so you can't really isolate it. You can't be like, oh, it's just physics and maths. No, it's a lot of different things, like satellites and geology and different things. We try to organize a range of different events and stuff by different people as well.
Great. Another question for the New Zealand Space Agency. Does the agency have any particular aims for the next decade?
So that's a good question. In the near future, we are going to publish a space strategy, which is going to define all of our aims and what we're trying to do. What we're really looking to do is move from this point where we were reactive and having to basically regulate the types of payloads that went up with rockets that were launched from New Zealand, and now to developing a whole downstream industry and where that comes from in New Zealand. I think that also relates back to a previous question about what kind of jobs we're going to need in the future, and that's something that's at the beginning you need small amounts of engineers, but it grows into a whole long industry of what you need. So you need people to process that data. You need people to show customers how to use that data, and that's an important thing as well to build on that we haven't really touched on yet. Also, we have large amounts of data, but what is it really useful for if there's no physical application? So it's also about teaching people what they can do with that data. And I think New Zealand has a lot of applications for that. And I think that when we start to think about what our strategy is and what's important to New Zealand, I think the most important thing is that we are, let's say, a responsible space actor, and we're putting things into space, and we're doing things that are good for the world using space technologies.
Great segue, because the next question is basically also related to being responsible and sustainable.
Okay.
What are the cultural implications of increasing New Zealand's involvement in space technologies, and how about its ecological implications?
I'm going to take that one just because a lot of the things that I'm working on are to make a more sustainable future. So if we're thinking about agriculture, right? So we've got a lot of great land here in New Zealand. We're trying to use it as sustainably as possible. When we think about having to colonize either a different planet or colonize space, you have to be 100% resource efficient. And so understanding how to be resource efficient in space, and understanding the implications and what you have to do to be resource efficient in space has benefits for being resource efficient on Earth. And I think that's not only for things to create life support systems, but for really any technology in space. So obviously we're not going to try to send stuff up just to see what happens. We want to be as efficient as we can for anything that we do get up in space. So yeah, I think for thinking ecologically, any space application by the very, manufacturing of anything that we do is going to have to be sustainable and as efficient as possible.
Remember, to get stuff into space is, thousands, $10,000 to $5,000 a kilo, just into a low Earth orbit. So that's pretty much the rough, And while that number has been dropped since the 80s, I think to put the space shuttle up was $30,000 a kilo-ish.
Something like that.
Huge amount of money, especially when you're sending up the space shuttle. So I think, that's the thing where you're instantly going into a mode where you've got to be as super efficient as possible. Everything has to be streamlined. Every piece of equipment has to fill that purpose perfectly for the least amount of weight, the least amount of energy. And so you do have a whole bunch of spin-offs that come into, into science in general and in everyday life that, wouldn't have come beforehand because there wasn't that need. So it's...
And also, for example, on the issue of space debris, where they have objects are being tracked in orbit that are just parts of dead satellites and things like that. There's about 20,000 in low Earth orbit, these objects that are at least this size. And but Rocket Lab and the New Zealand Space Agency have been very good about not contributing to the debris by launching to low orbits where the satellites will come back down. Rocket Lab is very good about disposing of extra parts of their deorbiting the other parts of their rocket and their upper stages, and there's also this recognition that with the technology advancing for these small satellites, there's even an idea of launching very low orbits that only stay up a short period of time, because in 2 years you'll have another generation of satellites, and you keep replacing these ones and don't contribute to this debris at high orbits. And so there's and just last week, there's now starting a space sustainability index for different launch providers around the world, and so you can see Rocket Lab being rated as doing properly, rather than New Zealand doing properly compared to some other launch providers that are not acting so responsibly. But it's also, it's the same kind of long-term perspective of protecting and preserving things in the future that really needs to be infused into all these space activities. And a big area, an issue is going to come up is in the next few years is a lot of focus on this one particular landing site on the south pole of the moon. That's only 1 kilometer by 5 kilometers, and I think 5 different countries and organizations all want to land there. So there are all these issues that we have to be aware of about protecting the space environment and acting responsibly.
I would also just like to add something there, especially when we refer to low Earth orbit, which is quite crowded already. It's in everybody's best interest to maintain that orbit to be clean. So at the moment, if somebody puts something up that makes a mess in the orbit, then nobody can use it. So everybody loses their space abilities. So I think we also see, for example, companies with propulsion. People are moving away from these technologies that are not so clean, and now you see a lot of emerging trends in space to be very clean. For example, we're using hybrid technologies like hydrogen peroxide, which dissolves into water, as a propulsion, a propellant, sorry. And then we also have some engines that are even starting to come out now without propellant. So it's, I think the general trend is really moving towards cleaner and greener, greener space. And New Zealand especially, we have a High Altitude Act that prevents people from putting any payloads that are going to dirty any orbits into space. So I think that's the general idea.
Okay, here's another question. Are the companies here tonight hiring? And will company create programs with the intention of assisting students to secure a job after graduation?
We, we have a history of getting students on scholarships at Orbica, so we've had 3 or 4 students come through which we've given jobs to. So, I mean, we're very keen on getting people in who are interested about remote sensing, GIS, and how we can take this and build products with it. So we're always looking for people. One of the key things that we are really interested in is we're a very multicultural company. I think I'm the token Kiwi there, or one of the token Kiwis. So we're a young company, lots of young people there, but the idea of there's all these cool technologies out there, let's put them to use and do good things. And our company's sort of byline is helping 1 billion people through geography, and being able to tap into free data that we can spread out to community groups is, that would be a fantastic thing for us. So we're really into that kind of sort of, the democratization of science. We don't like locking things down into silos. We use open source software apart from expensive stuff. So if people are interested, we're online, learn open source software, have good ideas, be curious about the world and space.
And I'll just add on to that, because you can speak on behalf of Orbica. We also have the Christchurch Aerospace Center, which is where we're starting to develop a strategy for Christchurch. There's actually more than a dozen companies in Christchurch that are doing space-related research, whether it's manufacturing gear for the rockets going to Rocket Lab, whether it's data. There's a lot of different companies here in Christchurch that are already in the space industry. And for a small city the size of Christchurch, it's actually pretty incredible what we're already doing. One of the easiest ways to get in touch with some of those companies are to come to, we have space meetups every month. Our next meetup is on the 7th of June on a Friday. Sophia, the plane from NASA, is coming back, so we're going to welcome the crew back. But then all of those companies will be represented at the meetup, and it's a really great way to interact and meet companies and see who's hiring. So I know we're wanting to keep people in Christchurch, and that's one of the things we're trying to do with the Christchurch Aerospace Center, is to keep good people in Christchurch and give them opportunities to grow and really develop the industry.
And surprisingly, post-earthquake, Christchurch has actually got a really burgeoning tech scene going on. There's heaps of really interesting companies around doing lots of interesting work. So it's actually it's a fantastically interesting sort of industry to work in at the moment because of that. You've got people doing amazing things with vertical takeoff, beyond line of sight UAVs and LiDAR mapping. There's lots of data visualization companies. There's lots of people trying to get involved with remote sensing data. There's lots of people wanting to use it as well. So Christchurch is actually a pretty neat place to kind of kickstart off, a really strong tech environment that will support any type of, space-based industry.
Here's an interesting question. What involvement is possible outside of STEM subject areas? Where can the humanities contribute?
Yes, there are a lot of, outside of just the STEM subjects. I mean, I didn't study STEM subjects myself, and I've been working with space for quite a while. So I think that a natural curiosity, and especially with the humanities, there's a lot of interesting people working with space data. Kurt has just gone through all of the stuff that he's doing, and I think it's not essential that you study this. While it's preferable and we need to build that, it's not essential. It's not the be-all and end-all of space jobs. So I think that I would be interested to hear. Maybe Kurt, I'm not sure that many of your employees are aerospace engineers, or not so many of them at all.
No, we have no aerospace engineers. We've had a couple of people who have worked for the Indian Space Program with us, but they were coming in as data scientists. You know, they're coming in as mathematicians. But we've got a whole range of social scientists through to, you know, geologists, through to freshwater scientists working for us. You know, but we all find a way to synergize and start looking at how we can start building tools around this data. And, you know, it's one of the things is the focus is on the data and the questions that we're trying to answer that requires the data. It's a bit of a sort of egg for the chicken kind of situation. So sometimes you discover fantastic stuff by just looking in the data as well.
Yeah, so I think it's very important that we're, in New Zealand especially, that we maintain this studying of STEM subjects, but yeah, there's also, it goes right from, we're not just launching rockets, there's also the use of the data, there's the, and for example, the humanitarian use of the data, somebody asked specifically, there's a lot of organizations around, and it's something we're looking to do in the future in New Zealand, but if you look at people like ISA have set up things like Earth Observation for Good, where there are EO4SD, Earth Observation for Sustainable Development, where they're looking at how we can use space data and space ability to help countries that have disaster problems or problems with farming due to water supplies or different ecological problems that cannot be solved without or could not previously be solved on such a big scale without the data. So.
Yeah, I mean, there's been a massive move towards that sort of sustainable agriculture. Landform monitoring is such a big part of what we do now, you know, and even Google has come up with an entire back end that you can get into called Earth Engine, which allows you to go in and basically build models that look for plant health, look for dryness, salinity in the soil, using a whole range of satellite data that's there, you know, and they've done this so grassroots organisations can start building them into tools and using them to tell stories, you know. And that the idea of using the data to educate and to aid communities in moving to sustainable practices, or even monitoring what's going on in their own backyards, is sort of such a major focus on what we do now.
Yeah, and I think in terms of how you can get involved with space, with humanities, I think that's really important as well. You have to, because space is just so multidisciplinary, you need different people with different experiences to contribute. So you got things like history. You need to know the history of the space program to understand how things work. And for example, art. Artists inspire us. People draw things like galaxies and stuff, and that inspires people to do things. So when we don't have actual images of things like stars and galaxies, NASA or like space people, they turn to artists to draw things for them.
Also, as the New Zealand Student Space Association recently joined the international group SED, Students for Exploration and Development of Space, and I was one of the founding members of that back in the 1900s, and so that was. We intentionally made that group open to any students, you know, interested in space, no matter what your background, and that's where you suddenly realize when you're trying to do these projects that you need the business perspective, the marketing, the space lawyers are so important, but also one of the, you know, it's really critical about the artistic point of view, because it turns out that you know, they've done surveys in the past, like Lockheed used to do this survey of how did people get interested in space, and almost everybody went back to the imagery or the visualization or the movies and things like that, which is why they started Lockheed invested in IMAX movies in space and things like that. But one big part of that was, for example, the visualizations of big space settlements that we used to be involved with our student group. And when we used to work with Jerry O'Neill and his idea of having, you know, cities in space of 10,000 people. And one of our chapter leaders was Jeff Bezos at Princeton. And so he got inspired by these visualization of these images of these space cities, and now he's just in the last week he was showing those slides about why he's putting $1 billion a year into going to develop lunar resources. And so I think it's really the artists lead the way in this in space, and also in science fiction too. One thing that's really funny to me is there's this series called The Expanse that I don't know if has anybody seen The Expanse here?
If you haven't, you should.
Yeah, but it's really tough to find to see in New Zealand. It's not
What's on Prime?
It's really difficult to get. But it's also surprising to me that one of the main characters, the woman who plays a Martian Marine, is from New Zealand, and it's like all the rest of the world knows about this New Zealander, and the New Zealand people don't. But anyway, it's one thing that it's not entirely a utopia, but it certainly is more realistic development of a vision of 40 billion people living through Earth, Mars, and the asteroid belt, and in 200 years. And it just sort of makes you realize that we're really at the point of defining what the future is going to look like, and the things like artists and the stories and the humanities and the sociology and the history is really going to make a huge difference into what the future is going to look like.
I think, the humans are also hardwired for that need to kind of explore.
Absolutely.
It's built into us. We can deny it, but it's always there, And I think, I've done 10 seasons in Antarctica, and I've worked with biologists, microbiologists, physiologists, whole range of the hard sciences, but filmmakers, photographers, sculptors, artists, anthropologists, psychologists, doctors, so there's a whole gamut of things that go there. And I think, the Antarctic community is an easier to get to macrocosm of what we see in the space program as well. And I think, there's that emotional connection that we see when we see those images of space. And you don't get that from the science sometimes, but you can see a whole table of data and go, yeah, that's cool. But when someone converts that to an image, it has a really sort of instinctual thing today. Like today, I just had a look at the daily image from the Opportunity rover, and I kind of do this because that's kind of what I do, and there's the hand lens imager which shoots soil, shoots the top of the surface, as again, this is what I do. Spending years looking at Antarctic soils, but I see so many things in this one little image of Martian soil that I see in Antarctica. And you see these images come out and go, I've been there. I'm sure I've been there. Is this a fake? And it's those images that really kind of get to you and really make you engaged with the subject. And I think that, that humanity of that and knowing your place in the universe and seeing amazing art generated from these amazing places is something that we should never lose. And we need that in, any kind of industry that's based around exploration.
There's a question here. I think this is for Sarah. And there's like 2 people, so I want to make sure that do you see a collaboration with the engineering department and biology department for tests in microgravity ever occurring at UC for students?
Absolutely. So that's one of the things that we're trying to develop right now is collaborations between the engineering department and the School of Biological Sciences. We've already had some really great collaborations with UC Aerospace, which is the student-run rocket club. So we've actually had the first biological experiments in New Zealand, both launched and recovered from our UC Aerospace rockets, which is a big deal for all of New Zealand. But again, that's a student-run club. These guys are building some phenomenal rockets and giving us the opportunity to perform some experiments. And we also had the School of Physical and Chemical Sciences involved in that as well. And that was just the start of these collaborations. I'm as a biologist, I'm working with people in civil engineering, mechanical engineering, electrical engineering, trying to develop these projects. And so there's going to be a lot of space for students to get involved in these projects. We just need a little bit of funding first.
So going back to the sort of like the overall high-level strategy for space in New Zealand, What does the panel see the ideal balance between public and private initiatives?
Okay. So traditionally, with what you describe as old space, it's always been it was always very expensive to do any space travel. So you have to think about all of the traditional NASA missions. That it's a lot of money from government put in. But now you see the focus is kind of shifting towards new space. So always when you launch very big missions, or you're trying to send satellites at 2,000 kilos into geo, it's not going to be a cheap mission. But I think that the balance is that you need to, in New Zealand we're never going to have, even if a space goes really, really well, we're never going to have this huge, huge budget that, say, the States or ESA within Europe has, or China or Russia. We're never going to have that kind of budget to throw at space just because of the size of our population. But what I think we can do is maximize the missions that we can go on, especially collaborating with other countries and utilizing some of our best aspects of space. So maybe developing some capabilities. We see already some in university that we have developed, and looking at where we can combine our best aspects with other countries' missions, and maybe even in the future work with them ourselves. So I think the perfect balance for me between public and private ownership is, I think that sometimes you want to facilitate to the best of your ability space companies to be able to flourish in your country. But I don't think you want to just give them money. You want to make sure that they're focusing on, well, if they're commercial companies, focusing on commercial ability, and sometimes that means helping them to nurturing them through other methods, maybe through funding, but also allowing them opportunities to collaborate with other people around the world, and also the opportunity to grow in New Zealand. I hope that answers the question.
I think, yeah, coming from the U.S., there is, I did have a lot of experience with the old space model, and, both on, I mean, space station was supposed to cost $8 billion, and it ended up costing $160 billion. Oops. And the same with the space shuttle launch was supposed to be $4 million a flight. It was $1.6 billion a flight. And I worked on one project for many years, $8 billion Earth-observing spacecraft, that one instrument was late and they just gave up and said, oh well, never mind, canceled the $8 billion project. So I don't recommend that model. But I think, and I think New Zealand has a lot of different useful tricks of, like matching funds on, Callahan Innovation Grants, and small amount of money to help students do internships in different companies and things like that. And there are various little ways, and also this contributions to this latest aerospace challenge, where a $30,000 prize came out with all these 18 different teams putting a lot of effort into developing new companies and products and services. And so I think that's really some smart way of just using small incentives, just to nudge things along, and let the natural let the private industry respond quickly to the opportunities, and just helping encourage that. So we're still learning about what is out there and trying to help people, match up with these incentives, but I think that there's opportunities there.
Yeah, and I think something also worth mentioning, at the moment we have the Catalyst Fund out, which is an initiative of MB, which is funding R&D for space-specific projects. And so we're looking to try and fund 6 to 8 projects with that, and I think the expressions of interest have already closed, and the projects will be decided in the coming months. So I think there's a lot of initiatives, and then we're looking at funding an R&D stage, so we can help guys that have great ideas just to get into business. But I think once you have these big companies that are operating by themselves commercially, they need to be able to have environments or regulatory environments where they can flourish. But you need to be funding the small businesses and the R&D where people are. Yeah, they don't have the money to survive without it. So I think there's a lot of initiatives. currently through the government, and there's a lot of different ways to access funding in New Zealand. And I think that we're only going to see an increase in that as the space industry grows, especially as space crosses over with a lot of other industries that are also funded in New Zealand, like agriculture, agribusiness, that kind of thing.
So Australia has just come out with this thing called the Digital Earth Australia. And this is an initiative sort of done by Geoscience Australia. So a government-sponsored organisation has now bought data for Australia. And they've built this server-based hypercube, which everyone can just put their data in and access it. And so the idea is you've got the government putting in the infrastructure and the data in place, but allowing commercial and public enterprises to link into this data cube and start developing application services based on top of this. And so this is another way where you can have that public-private partnership, especially at the data level where it's a bit easier than the hardware level. But it allows the expansion and that proliferation of that data to actually be used, and that's where you start getting the interesting questions being asked because the data's out there. And it seems to be a really interesting thing. It'll be fantastic if we could do this kind of thing in New Zealand where every organisation could stick their stuff in one space and you can add it. I can go in and get high resolution imagery from here. I can go and get doc records from here and overlay them with Ngaitahu records from their historic records. So I mean there's a whole range of things that can be done in that space, so it's an interesting sort of concept that they've come up with.
Let's go back to education and for people who are starting out just basically in their career. So here's a question from, what should a teenager do, study, join, etc. if they want a career in the space industry?
I'll start just because it really depends for me. So just take my experience of going to the Johnson Space Center, and that runs the gamut of the space industry. I mean, you have the manned space program, you have data analysis, you have the scuba divers that are in the neutral buoyancy lab helping to train the astronauts. So you have basically any career that you can think of, NASA's doing it, right? So my biggest piece of advice is find an aspect of the space industry that you really are really interested in, something that you're really curious about, something that you spend till midnight looking up on the internet, trying to find a bit more information about it. Find something that you're really, really interested in and something that you can really, something that if it's going to be long and hard that you're still going to want to pursue that. Find that thing, and that's what you should go into. Like I said, that could be any career. That could be art, that could be science, that could be engineering, that could be law. Find that thing that you're really passionate about. I know it seems sort of cliche, but find something that you're really interested in, and then find a program that will help you do that to your best of your ability here.
Yeah, I think you don't often see people that just pick one area and they stick with it and end up in space in that way. It's everybody I talk to in space has always had this like big goal of being interested in the overall area, but have moved around, zigged down around. It was like I used to think that I had to go in a straight line of going through the degrees and end up and when I looked around at the end in the graduate program, I realized that I was the only one that had tried to do it in a straight line. Everybody else had already zigzagged around, and that's the same way with and I think that's why groups like the Student Space Association are so important. I was actually, studying astronomy, but I was interested in things like the space station, and so I was learning as much as I could about the space station. And so when I went for an interview, I was hired as a senior engineer just because I had been spending time in the Student Space Association. And so it was because I knew more about the space station than the interviewers. And so, but you just follow these different paths, and suddenly you pick up something that you were interested in the past. I used to be interested in Earth-crossing asteroids back when we thought there were 12 of them, and now there's 20,000, and so it's another 12 were discovered a couple days ago, I think. So I'm always, space is big and holds your interests, and so you just pick, one thing that's interests you, follow that for a while, and then you'll find something else that will interest you. And that's when you suddenly realize, if you're trying to do these projects, that you don't need astronomy and engineering will get you a certain distance, but then suddenly you're in a position where you need to know project management and business, and or suddenly if you're worrying about the sociology of worker communities in the outer solar system, it's you need to study the history too.
Yeah, I mean, completely. It's, and often at a young age kind of what you wanted to do. I knew early that, doing planetary geology would be really cool. Did I ever do it? Nah. I got a PhD in geology, but it's like, I eventually got to that point. And as Eric said, you bounce around. And I remember saying to someone, you don't like the science you're in, you always change. You can sort of navigate your way through different interests to where you are. And one of the things that had always helped me through my career is I'm terrible at networking. I'm terrible at talking to people. So you guys terrify me. But the ability to talk to someone and someone goes, we have a position that's coming up for free, would you come and work for free for us? Take it. Because that gives you experience, and it's these little jobs, making a network here, getting your name here, and bouncing around until your name's known around the industry you want to be in is so powerful. It allows you to go places that, having however many letters behind your name will never get you, just because you're in the right place at the right time and someone knows your name.
Yeah. So when I was a high school student, which wasn't that long ago, only 2 years ago, I was really keen on doing astronomy. I knew I wanted to pursue that as a career. And so I looked a lot at the internet, started learning about different things, but the internet isn't enough. And so I started looking at different things I could possibly be involved with. And so I joined my local astronomical society. And that was a great thing that I did, I think, because I started learning about telescopes and the night sky and basic things to get me interested in learning more about astronomy. Some other things I did was I basically just went to a lot of meetings and events like these, and I talked to different people. Hey, what do you do? What are you doing? How did you get started in astronomy? Things like that, and what kind of advice would you give to high school students? And I learned quite a lot that way as well. So the more you talk to people, like they mentioned, the more you learn. And networking is key as well. Super important. And that is basically one of the reasons why my colleagues and I formed the New Zealand Student Space Association Christchurch branch, because when we were high school students, there was quite a lack of support for students interested in astronomy. So I wasn't quite sure where to go, who to contact, what kind of people to talk to. And that's what we're trying to do, provide a platform for interested teenagers like yourselves to come in, learn about astronomy, talk to different people that we invite to our events and things like that. So yeah.
Anything else?
No, sorry.
So I know we're almost out of time. And so maybe I'll invite the panel to give their just last remarks or anything else that you want to tell the audience before we wrap up.
We'll start down to 10.
Oh,
Go the other way
The
around.
other way.
So my final remarks would be, I think as you've heard this evening, there's a lot of opportunities to get involved with space things. I think that you should really, if you're really interested in it, to look into it, because I think there's fantastic things happening in Christchurch and around New Zealand. And it's like events through these and through joining an association and getting contact with different people that we build this space economy in New Zealand. I think it's a great way to utilize some of our talent that we have, I guess, in this room as well. It's really, we have a lot of space interested people, which is awesome. So I think that, if you guys are interested in space, this is my closing remark. Just research what you're interested in and try to get into an area that really stimulates you, because when you're stimulated about a topic, you stay interested, and that's what's important.
Yeah, I would say definitely keep your eyes open to any kind of opportunities you get or any people you meet, because you can learn a lot that way. To cultivate your passion for space or astronomy or whatever your passion is. Yeah.
If you had told me when I was your age that New Zealand would have a space program, I would have laughed quite a lot. And so now we're actually at this time where technology is easily accessible to you guys. The knowledge is easily accessible. Yeah, it takes a bit of work to ferret through it and find the nuggets, but you're at the period where it's only going to get bigger. The industry in New Zealand is just started. Rocket Lab is like 28 satellite launches, but that's the start, you know, and we're at the point where we're only going to see an increase in satellite launches. We're only going to see an increase in the ability to do stuff in space and the need for space data. So it's a pretty exciting time, I think, especially in New Zealand, to be sort of, you know, having a foothold, even though it's a tenuous foothold, you know, in that industry.
Let's see. I was involved with student space groups long ago, and it did occur to me that all my friends that I knew from the student space groups, I interacted with them, and they're still involved in space projects for 30 years, and in fact, there's one guy who I've worked for him twice, and he's worked for me twice. You know, we just would bounce back and forth, and these are also my friends are also started, you know, asteroid mining company, and Bob is going to try to launch to the moon from New Zealand. He's bought 3 rides on Rocket Lab. So these people, you know, that was the surprise to me, was that the friends I made in the student group, and we argued over logos and things like that, and you know, silly stuff. They ended up being the same people that would make the big space companies that would do these things. But I think all the history of space that we're going to come up on the 50th anniversary of Apollo 11 soon. We have this tremendous history of the big space projects, but I think we're at the verge of a huge expansion of space activity, and I think the young people here are going to see some amazing things happen. I think it's actually going to be a lot more activity than Apollo or all the history that you've seen before. And so, you know, if you're interested in space, stay involved and be aware of what's going on. And I think there's going to be lots of opportunities in the future. And I have a feeling that a number of people in this audience are going to go into space personally. So.
I'm really excited about that prospect myself. Just sort of going back to, you know, what we've talked about over the course of the panel here, sort of the current state of space in New Zealand. We've obviously got a launch facility. We've got Rocket Lab, which is actually launching things into space. We've got companies that are manufacturing things for space for both the launches and then the actual satellites, and then actually looking at the data. So that's sort of current, right? And obviously there's going to be a lot more jobs for those sort of things going into the future of New Zealand. And we can really develop specific niches in really all of those for, like I said, for launches, for space vehicle manufacturing, and then also for data analysis, both looking up and looking back down. But what really excites me about the future of space in New Zealand is really just sitting here in this room, right? So we think about the future of space in New Zealand. It's really, we're going to try to lay the groundwork. We're going to try to develop this industry, develop this space economy here, and then we're going to hand it over to you guys, right? So the jobs that you guys are going to have may not have even been invented yet. So what our job here is to develop this industry and get it started, and then hand it over to you guys. You guys are the future of space in New Zealand. And for me, that's really exciting. And then just one last little thing, because I know a lot of you guys raised your hands, you know, wanting to become astronauts. So Chris Hadfield, who is a Canadian astronaut, started training to be an astronaut before there was a Canadian Space Agency, right? That's how much he wanted to be an astronaut. I know we don't have a manned space program in New Zealand, but we're developing a lot of international partners, and someday we will have Kiwis in space. And I hope it's one of you guys in this room, because that would be really cool.
Wow, that's an awesome summary. I can't beat that. So I think we should all thank our panelists tonight. I'm really sorry that we didn't get to all of your questions, but we're going to have refreshments after the presentation, so I'm sure that our panelists will still hang around, and if you have a burning question, please don't be shy to come up and ask. So thanks again for coming, and yeah, the future is bright. New Zealand is going to space one way or another. Thank you.